Throughout the semester in this course, we're going to be exploring a lot of different types of functions and their equations. First, we're going to start though with linear functions, or in other words, lines. Linear functions can be expressed in a few different forms, but for this first video here, we're going to start with what's called the point-slope form. Again, this is just one of a few ways that we can express a line as an equation, but the point-slope form of the equation of a non-vertical line with slope m. Now, we talked a lot about slope in the last video. One thing that we didn't say is that typically we'll refer to slope using the letter m, so that's just the variable we often represent the value for slope with. We'll see that here in the point-slope form, as well as in the next video in the slope-intercept form. But the point-slope form of the equation of a non-vertical line with slope m passing through the point x1, y1 is y minus y1 equal to m times x minus x1. Now, just to distinguish here, this y1 and this x1 are specifically this point that the line goes through. So if the line happened to pass through the point 3, 4, for example, we would replace x1, y1 with 3 and 4. That x1 and the y1 are just meant to be labels representing some coordinate pair. On the other hand, the y and the x that aren't labeled, those are the variables. Those represent like the input and the output, or those represent the values along the horizontal axes versus the values along the vertical axes. But this form of the equation, y minus y1 equal to m times the quantity x minus x1, is a line, and it's what we call the point-slope form of a line. Now, the reason we call it point-slope form, and this is one of the great things about math, is a lot of times we name things in such a way that it describes what they are. So when we use the point-slope form, that's because the equation itself has a point, x1, y1, and a slope, m, written right into the equation. So because the equation itself reads us the slope and a point that it goes through, we call it the point-slope form. And so how can we actually utilize this? Well, if, for example, we were given the slope of a line and a point it passed through, it would allow us to get the equation really quickly, right? So if we wanted to write the equation of a line that had a slope of 4 and passed through the point -1, 3, we could use our point-slope form. Now, remembering that our point-slope form, and I'll just abbreviate this as P-S, but remembering that our point-slope form is y minus y1 equal to m times the quantity x minus x1, all that we'll really need to do here is plug in those values for y1, m, and x1. Right, in this case, we'll substitute m is equal to 4, x1 is equal to -1, and y1 is equal to 3. And so we have y minus 3 equal to 4 times x minus -1. And now we can simplify this expression a little bit. Right? We've got this minus -1 here, and so we can clean that up by saying y minus 3 equal to 4 times x plus 1. But then we'll even want to take it a step further than this. Right? This formula here, the downside really of the point-slope form is that it's not written as an explicit equation for y. Right? This is an idea we talked about in one of the previous videos, where oftentimes when we describe a function, we want the output to be isolated or by itself on one side of the equation and have the other side be just an expression that describes how we're going to process the input. And that's not the case here, right? We've got an expression on both sides of the equation. So what we'll probably want to do, just to clean this up, is to solve for y. And so we can do that here by simplifying both sides of the expression first. This leaves us with y minus 3 still on the left, but then 4x plus 4 as we distribute on the right. Then adding 3 to both sides, this gives us y equal to 4x plus 4 times 3, or 7. And so we could write this as our final answer, an equation of a line that has a slope of 4 and passes through the point -1, 3. Now, point slope form works really well when we have a point and a slope, but it also can be really useful if we are given 2 points. So let's see if we can write the equation of a line that passes through -2, -1 and -1, -6. Now you might be wondering, how exactly are we able to pull this off if we're not given the slope? And as we kind of said, point slope, it's in the name, so we're really going to need it. Well, we can remember back to our last video where we defined what slope was. And we said that slope was equal to just the rise over the run, or in other words, the change in y over the change in x. And so if we do exactly as we did there and label these maybe x1, y1, x2, y2, then we can plug in those values to compute the slope. And so we'll start there. We know that m is equal to the change in y over the change in x, or in other words, y2 minus y1 divided by x2 minus x1. And so we can plug in y2, or -6. We can plug in y1, or -1, right? And remembering our parentheses here, we're doing minus -1, divided by x2, which is -1, minus x1, which is -2. Again, remembering our parentheses here. And then all that's left is our arithmetic, so this will become -6 plus 1 when we simplify, and -1 plus 2 when we simplify, giving us a -5 in the numerator and a +1 in the denominator for a slope of -5. And now that we have our slope and a point, in this case we actually have 2, but we only really need 1, we can utilize the point slope form. And so if we start with y minus y1 equal to m times x minus x1, we can go ahead and substitute in y minus, and here we can pick either of the 2 points we were given. So I'll just pick the first one here and use -1. I would encourage you at home to try and do this using the second one just to see if you can get the same answer. But y minus -1 equal to a slope of -5 times the quantity x minus x1, or in our case, -2. With a little bit of simplification on both sides, we can change this to y plus 1 equal to -5 times x plus 2, and then distributing will give us y plus 1 equal to -5x, and then -5 times 2 giving us a -10. And finally, subtracting 1 from both sides for a final answer of y is equal to -5x minus 11. And so we have our final equation of our line in an explicit form. Y is equal to -5x minus 11. And if we want, we can even go ahead and check to confirm that this is right by taking either of our points, or maybe in particular the other point that we didn't use, and plugging that into our equation and making sure that it does in fact work, that the statement y is equal to -5x minus 11 is actually true at this value. And so if we plug in -6 for y and -1 for x, is this actually a true statement? Well, -5 times -1 gives us a +5, and +5 minus 11 gives us -6, and so we do end up with a true statement, -6 equal to -6, and so this works. And so here we have the main uses of the point slope form. When we're given 2 points and can compute the slope, or where we're given the point and the slope, using the point slope form is going to be a really good way for us to write the equation of that line. Of course, it's not the only form of a line, and we'll see some more in the next coming videos. So I'll see you then, and I hope you have a great rest of your day.